Okay, this is a Unit 2 review for MAT 171, and we're going to start with we're going to write the partial fraction decomposition of the given rational expression. And let's say that we have here a function such as 6 over x squared minus 3x. Okay, the first thing we want to do here is we want to go ahead and factor this denominator. So this would be 6 over, and then we want to factor out the common factor, which would be what? We should have said x. So this would be x times x minus 3. And now we want to write the two parts of our partial fraction decomposition. So you take each denominator, and so this would be a over x, each factor in the denominator, plus b over x minus 3. And then we want to, the easiest way to do this is to look at each denominator, set each denominator equal to 0 and solve. So we get x equals 0 and x minus 3 equal to 0. And so we would solve this x minus 3 and we get x equals to 3. So the purpose of this is we want to eliminate either the a or the b, or both. Since there's only two, we want to eliminate just either the a or the b. So the first thing we're going to do here is we need to multiply out the denominator. And it's easier to go ahead and multiply it out when it's factored out. And so we would multiply out this denominator. Here we'd multiply x times x minus, actually let's do this on the right, x times x minus 3, x times x minus 3, and x times x minus 3. So here the x times x minus 3, those all cancel out, and so we just get 6 on the left side. And here the x's cancel out, and so we get a parentheses x minus 3 plus, and here the x minus 3's cancel, and we get bx. So now we want to take one of these two factors of the denominator and go ahead and start substituting them in to eliminate either the a or the b. So we'll start with x equals 0. So we substitute 0 in wherever there's x. So this would be a parentheses 0 minus 3 plus b times 0. Well, b times 0, that just goes to 0. So that just leaves us with 6 equals to a times the negative 3, or you could say negative 3a. And so now what we want to do is isolate the a, so we divide both sides by negative 3, and we get a equals to a negative 2. Alright, so now we have a, but we need to find b. So we can use the other factor for the denominator, x equals to 3. And so we plug that in. And so here we have 6 equals to, and we know that a is negative 2, so we can just substitute that in. We're going to put 3 minus 3 in here for x plus b times 3. Well, here this cancels out. This negative 2, 3 minus 3, that'll be 0. Negative 2 times 0 plus 3b. Alright, so now we can isolate the b, and we divide both sides by 3. Divide by 3, divide by 3, and we get b equals to 2. So our answer from up here, 6 times x squared minus 3x equals to, we said a is negative 2 over x plus 2 over x minus 3, and that's our answer. That's all you have to do for that. Okay. Let's say that we have, next let's take a look at piecewise defined functions. First, we'll look at substituting some values in, such as, so this first one, we'll call that problem 1. The second one, we'll call that problem 2. And we have here h of x equals to a negative 2x minus 3 for, now you could say if or for, it really doesn't matter, x is less than, let's say, negative 2. And then we have here, let's say, 3 for x is greater than negative 2 but less than positive 3. And the third one, we'll say x plus 5 for, this should be greater than or equal to negative 2 here. So this would be for x is greater than or equal to 3. And let's say we want to find h of a negative 8, let's say. Well, first thing you have to do is look for each one of the 3 of these. Since negative 8 is less than negative 2, you would use the first function. So this would be negative 2 times negative 8 minus 3. So negative 2 times negative 8, that would be positive 16 minus 3, and we get 13 out. Alright, now let's say that we want to find h at negative 1. Well, we want to see where does x at negative 1 fall in? Is it less than? Is it greater than or equal to negative 2 but less than 3? Or is it greater than 3? And you should have said the middle one. Negative 1 is greater than negative 2 but less than 3. So therefore, since there's no value for x to put in here, there can only be one answer, 3. So if you were to look graphically, here's 3. This would be negative 1, 3. So no matter what value you have from negative 2 to less than 3, your answer out is going to be 3. Alright, and then for h is, let's say, 3. So you're saying, okay, which one of these 3 would you use given x is at 3? Well, here x is greater than or equal to 3, so you would use the third one. You can say use values that are greater than 3 or equivalent to 3. So you would put in here 3 plus 5. You would use the third equation, and we get 8 out. All right. And that's basically, there's more, but we're just basically, those are the three that covers all three of these parts of the piecewise defined function. Alright, now let's take a look at a piecewise defined function, but we want to graph it. And here we have f of x is equal to, and we want to say x minus 2, 4. X is less than or equal to 0. And we'll say 1, 4. X is greater than 0, but less than or equal to, let's say, 3. And 1/3, 4, x is greater than 3. Now, when you're, oops, x should be x here. X is greater than 3. Alright. So, you want to, for graphing, you want to split it into three functions, such as f of x is equal to x minus 2, 4, x is less than or equal to 0. Alright, that's the first one. And then here we have f of x equals to 1. 4, x is greater than 0, but less than or equal to 3. And then the third one is f of x is equal to, this should be 1/3 x here. 1/3 x. 4, x is greater than 3. Okay, so basically, if you're looking at the graph, what you have here is at 0, that's covered by this f of x equals to x minus 2. And so that's including 0 and less than that. Here in the middle, and then you've got 3. You've got your function f of x is equal to 1. And that should be x here. And that's going to be in between, where it's going to be open here. It's going to be open but closed. I don't want to use an arrow, but closed on the other end. So it's going to be somewhere in between here. And then the third part, f of x equals to 1/3 x, that will be greater than 3. So we want to use our table of values. And so we want to start with our restrictions. 0, and since it's going less than 0, it would be -1, -2, and that should be enough. So so we put in 0 here and we get -2 out. At -1, -1 and -2, we get -3 out. And -2, -2 and -2, we get -4 out. So on our graph, we say we look at a restriction, and that at 0, x is less than or equal to 0, so that's closed. So that'll be a closed dot at 0. And so we're going 0, -2, and that's closed. And we'll use red for that. And then -1, -3, and then -2, -4. So we get, and because it's less than 0 and there's nothing restricting beyond that, you get an arrow. Okay, now let's look at the next one, f of 1. So here's our table of values for f of 1. And so we start with 0 again, but because x is greater than that, it's open. And we go 1, 2, 3. So no matter what x is, y is always going to be what? Y is always going to be 1. So this would be 1, 1, 1, 1. And so it's open at 0, but what do you think is going to happen at 3? Is it going to be open or closed? You should have said it's going to be closed because x is less than or equal to. So that's closed. Okay, so we have here x is 0, y is 1. So that's open. X is 1, y is 1. X is 2, y is 1. X is 3, y is 1. And that's closed. So notice there's always going to be 2 points. One's open, one's closed. Here, this is closed, so guess what? The other one is going to be, in this case, is going to be open because x is greater than 3. So let's look at this function. And so for f of x is 1/3 x, we put in our table of values, and what do we start with? Because the restriction is at 3, we start at 3. And that's open. And because x is greater than that, we're going to go 3, 4, 5. And now, since 3 is the denominator, it's easier if you use multiples of whatever your denominator is, like 3, 6, 9. So that will evenly divide into the denominator, like 1/3 times 3, we get 1 out. So that's 3, 1. 1/3 times 6, 3 goes into 6, and that's 2 out. And 1/3 times 9, we get 3 out. Okay, so that's because it's greater than, it keeps going, that's going to have an arrow to it as well. So that'll be 3, 1. So that'll be 3, 1, and that's open, and so that's going to be an open circle right there at the same point, 3, 1. And then 6, 3, 4, 5, 6, 2. 6, 2, and then 9, 3 will be out here. So you get that. Now, you may not, because I made this up off the top of my head, you most likely will not see one point on top of another one like that. It'll be up higher, down below. So just keep that in mind. Alright, but this is what your piecewise defined function looks like. Okay.